じゃあ始めたいと思います。English session と書いて日本語で喋ってるんですけど、let's start speaking in English. Good morning, everyone. Thank you for coming to my session, and I'd like to say thank you for joining DroidKaigi 2023 as a member of the DroidKaigi committee. And let me quit from the staff role for now. So today I will talk about the Gradle Convention Plugins. Before stepping into the main content, let me explain a few ambiguous terms for Android developers. The terms are project and module. So in the context of multi-modularization, many Android developers use module to represent Gradle's projects, shown as root project or sub-projects. If I follow Gradle's language, you would be confused because you have to understand whether a project is of Gradle or not. When I say when I say a project. So, in this presentation, I will use project to represent a set of files and directories to build your application. This may be the same as a Git repository for some application projects. And the module and or build component will be used to represent a directory corresponding to project class of Gradle APIs. So as Android module, future module. Okay, let's get started with my self-introduction. I'm Jumpei Matsuda from DroidKaigi, which provides a mobile app distribution service named DroidKaigi. I've been spending time on Android application development for about 10 years. I'm now writing a Gradle plugin which depends on Android Gradle plugin at DroidKaigi. And also, I'm in charge of development productivity engineering in my company. So today, I'd like to introduce and share Gradle and plugin knowledge from my experiences. This presentation is focusing on why over how. I will talk about what for Gradle Convention plugins and or why existing techniques can improve build performance. You may have been writing the code shown in this slide. This style is called script plugins. These codes can reduce duplicated code across multiple Gradle modules. Left figure shows a kind of centralized configuration. It configures all modules by just writing the single code block. Or you have written shared Gradle files and apply them from each Gradle module. These are not deprecated and obsoleted, though Gradle recommends to write plugins for this purpose. It's called Gradle Convention Plugins. Let's follow the official document. Please see the underlined part. As the official document says, Gradle Convention Plugins are just plugins written for your specific needs. It doesn't mean it's a special implementation of a Gradle plugin. It's the same as the regular plugins. So, convention plugins can also perform same actions as regular plugins can do. Then, what's your specific needs? It depends on your project. For example, sharing the same configurations to each modules and stepping in Gradle tasks and Gradle task graph on demand. Or creating anti-corruption layer of third-party plugins. So it means, why should we write plugins? For example, shared Gradle files can achieve the same goals. Let's see the official document again. I know you want more context to read this statement, though. The important point is to recognize modules as build configuration. Regular modules cannot configure the build of the project, the entire build, because it violates the dependency direction. However, composite builds can do. Modules in composite builds are separated from other regular modules and can interact with the build of the project. Composite builds one of the long-lived mechanisms of Gradle. If I remember correctly, it's available since 3.6 or 7. As you may know, Gradle creates a directed acyclic graph of tasks to be executed and builds them based on their dependencies. This figure shows dependency graphs consists of 6 modules. A depends on B and C, and let me omit it. So finally, the execution order is F and D, then B or E, then C. Finally, A will be built. The ordinary builds are like the figure shows. So, however, for composite builds, Gradle builds modules are registered to composite builds first, and then complete the remaining builds, as if we could build multiple projects in monorepository. Once plugins in composite builds are compiled, then they will work as if they being distributed through Maven repositories. I mean, we can say that convention plugins are just best practice of sharing logics between multiple Gradle modules and can provide the build configuration on the convention we define. So, convention plugins should support project-specific needs and should be built as composite builds. Then, convention plugins will behave like the pre-built binaries. It sounds great, right? If you could create plugins in the proper way. If you do not know practices enough, then it would be an unwanted convention plugin, if anything. Such plugins will be highly frequently recompiled, and/or its recompilation will be so heavy. For example, incremental builds are not supported, recompilation long, even if you do not modify codes. Or plugins are built with ineffective cache due to the long usage of some leading dynamic values like environment variables. Unwanted convention plugins will make higher costs and reduce your productivity, as some publishers have reported. So, convention plugins should be effective and follow the requirements. They should not be recompiled if no code changes happen. Recompiling them should be low cost, for example, by using cache. An effective plugin uses constant values as a compile time as much as possible, of course. And also, if many modules can share plugins, then they would be great, but it's not mandatory. These requirements are also required for Android app development itself, right? So, I'd like to say you already have enough experiences and mindsets for the build improvement. It's okay to just run and use Gradle-specific knowledge, like a Gradle build mechanism. Sounds difficult? No worries, I will explain them in this presentation, maybe. Let's see the Gradle build lifecycle. This figure shows an overview of Gradle build lifecycle if composite builds available. Gradle build consists of the 3 distinct phases. They are initialization, configuration, and execution. In initialization phase of a project, Gradle will detect settings.gradle files and composite build modules. And then it creates a kind of the build graph for the further purpose. Composite builds will be built before completing the configuration phase of the project. the build of the project will wait for composite build's completion. After composite builds complete, the out of composite builds are automatically added to the class path of the project. And then configuration phase, configuration phase and execution phase will be processed in order. So to improve the Gradle build performance, we should consider caching for each phase to speed up. This figure is when you can implement convention plugins properly. If convention plugins generated by composite builds can properly use build caches, then Gradle build will skip compilation and can reuse the outputs of previous composite builds. And also, the outputs will be used in configuration phase of the project. Configuration phase of the project can use configuration cache for the performance improvements. And the output of build Gradle will be used in the configuration phase, as I said. So, composite builds should provide a convention plugin that have configuration cache compatible API for the project. If the convention plugins are incompatible with configuration cache or without configuration cache support, then you can imagine that they damage the build performance of the project. So the plugin implementation should be build cache friendly and should provide configuration cache compatible APIs. So now we have to understand two things. One is how to enable composite builds. Another is how to write plugins. Before explaining the composite builds, let me have a break. To use composite builds, we can use predefined directory. It's build source directory. It's registered to composite builds by default. Second option is manual registration. We need to include build APIs in settings Gradle file. But we can use any directories for composite builds. Which is better? Let's check the build source directory first. Build source directory's behavior has changed since Gradle 8. This is breaking change. As for Gradle 7 or older, build source build task was on hot path, so it would be frequently executed. In particular, Gradle may run check task, which include test task, on CI again and again. So I do not recommend use this one, at least with Gradle 7 or older. For Gradle 8 or later, only tasks that generate some artifacts will run by default. It's the same as other modules of composite builds. Build source is great if you are using Gradle 8 or later. How about manual registration? Yes, you can call include build API multiple times. I mean, you can create multiple plugins in multiple projects independently. However, it may take the configuration phase longer than using the build source directory. At the end of the 2021, Square reported composite builds made unacceptable degrade when migrating from build source. Please note that Square gave program for convention plugins itself. So both build source and the manual registration are fine, but we should not use composite builds with multiple projects. Only one included build is better. Next is plugin writing section. We have to think about the plugin project styles, programming languages, and preferable APIs and or code smells. We basically have two choices for the project styles. One is precompiled script plugin, and another is standalone plugins, as known as binary plugins. Precompiled script plugin can be created easily, super easily. You have to create a file. The base name of it will be plugin ID. That's it. However, it may be low readability if your code is getting bigger and cannot manage build cache. Standalone plugins, as known as binary plugin, requires a project or module. You have to implement plugin class and define it as an artifact. You can write large size of codes for it, and you can manage build caches because it's just a project as you write the Android app projects. So we should use a standalone plugin instead of the precompiled script plugin because standalone plugin can get benefits of build cache. It makes sense. Next is programming language. For Gradle plugin development, we can use any JVM languages to develop Gradle plugins. Gradle provides 3 plugins for each language to develop Gradle plugins itself. That's Gradle plugin is a type. So I guess any part will be Groovy. And Kotlin DSL for Kotlin DSL, and Java Gradle plugin for other JVM languages. So for Android developers, Kotlin DSL, maybe you often see it in many times Android projects. And also, Gradle recommends the static type JVM language, even though they are using the, how can I say, adapted Groovy for the default language. So. Because static type JVM language is preferred for compilation avoidance and time to inference costs at runtime. If you are already using Kotlin DSL in your project, then Kotlin is preferred. You don't have to switch to Groovy or dynamic typing world. Groovy is okay, but you have to annotate with compile static when developing plugins. Static typed language is preferred and Kotlin is great, at least for we Android developers. And then let's check the preferable APIs and code smells. As I said before, convention plugins are not special plugins. It's not special plugin implementation. We will use the same Gradle APIs. However, convention plugin should pay attention for the performance much more than standard plugin development. I mean, third-party plugin like us. Gradle's official documents show many examples, but I have seen somewhat deprecated or non-recommended codes, so it's a good reference, but may not be a kind of the authority in your team development. You have to explain why this code is, based on the good practice or not. So I quoted from the document is not totally, doesn't become a reason. For preferable APIs, you should use a lazy configuration API as much as possible. For example, you shouldn't call tasks.create get by name and when task added. Please use tasks.register name and configure each instead. And let me have a break. Okay, and when reading external variables like system properties and environment variables, please use provider API and delays evaluation as much as possible. And also, Gradle provides many lazy configuration APIs for the build performance improvements. Just using these APIs, you may be able to improve the build performance unbelievably. So switch to the code mouse. Oh, sorry. No, I saw wrong. That's right. The second statement. So when defining tasks, please create a custom class. Input and output annotations will be recognized as configuration cacheable. Missing annotations cause a build failure by default if you are using Gradle 6 or 7 or later. So please do not opt out it. And please support configuration caches. If you do not have intention to support configuration cache, then I do not recommend composite builds anyway. So let's go to summaries section. If you see code which get or transform values that are inputs of the task immediately, then Gradle may provide a lazy API, so please use such Gradle's lazy APIs if possible. And if statements are basically okay, of course okay, but if you use it to determine whether or not to apply configuration, then it may not be good. It would be better to separate the plugin into multiple plugins or to consider exposing interfaces with lazy configuration APIs. The use of reflection API is also a code smell for convention plugins. Convention plugins can know which version is resolved, and it should be. If you need to use reflection anyway except when accessing to hidden API, then please reconsider the dependency management first. This is the last section on Android Gradle collaboration. You may be thinking about using lazy configuration API when integrating to Android Gradle plugin. But no, we basically do not use lazy configuration we do not use lazy configuration API directly for Android Gradle plugin. They provide their own APIs for the configuration over Gradle APIs. Because Android components like variables, variants, have their own lifecycle. The lifecycles are finer grained than Gradle's API, so it's hard to manipulate from Gradle's infrastructure. Android Gradle provides lifecycle-based APIs. As you can see, this figure. For example, finalized DSL will be called first. Basically, you don't need to do something here, but you should remember extensions like project.android is freezed, is programmatically freezed if this is code. So you cannot, maybe you cannot assign the new values to Android extension, or such values will be ignored. So you may do a lot in before variants or on variants callbacks. These are called after finalized DSL. For example, if you calculate version information by your custom task, then use outputs to configure variants in on-variants callbacks. And we should remember that we don't have to manipulate tasks generated by Android Gradle plugins directly. They do not provide task inputs for us. It should be manipulated from the Android Gradle plugin. You may want to touch such tasks when you use the outputs. Then please capture variant names or some values which are available in callbacks I said before, so on variants and before variants. And use it for filtering in tasks configure. And there are a lot of practices that I couldn't share in this presentation. For example, we should use newer Gradle anyway. Newer Gradle may have bugs though. Newer Gradles tend to have powerful features to improve the build performance. They are doing well for the refactoring or introducing new features. And another option is using the Maven repository is also great. I know some companies have been using Maven repositories for convention plugins instead of composite builds. So they publish the build plugins to Maven repositories first, and members will use build binaries. So it's not a composite builds mechanism. It means they management such artifacts by themselves. It requires expertise techniques, so it's really effective if actualized. You have to consider the workflow in your company, because you may want to modify the code of the plugin and test it in your project, but build binaries through Maven repositories should be replaced at the time. Lastly, the analysis of Gradle Enterprise is very useful. It can accelerate your development. Okay, so I know 10 minutes left, so going to wrap up this presentation. There are 2 slides left. As Gradle says, plugins are recommended when sharing logics between multiple modules. It's called convention plugins. I strongly recommend you to follow the best practice of Gradle builds and know and track the Gradle's update, because poor Gradle Convention plugins cause slow build and reduce your productivity. If you would like to improve the build performance of your project when using the convention plugin, then please create and improve your convention plugins. And understanding Gradle's build mechanism will be your help, I believe. They are, for example, Composite builds, Lazy API, Android Gradle Plugin APIs also, and the build lifecycle. And also, you should not forget that the best practice are to handle caches a lot. Cache is all you need. Lastly, please get in touch with me at the office hours or today's after party. Thank you so much for listening to my presentation. That's it.